In today's video, I'm going to continue with the previous year question series, Board Exam MBOSE Year 2022. Question number 20 from organic portion. The first one, arrange the following in increasing order of their acid strength. Now, which one is more acidic and which one is the least acidic? From here, ethyl alcohol is less acidic than methyl alcohol. Methyl alcohol is less acidic than water, and water than phenol. What is the reason? Why is phenol more acidic and why is ethyl alcohol less acidic? Okay, just have a look here. Structural formula for phenol. Okay, oxygen is more electronegative than hydrogen, right? So what happened? We get a phenoxide ion and a proton. This is a proton. Now this phenoxide ion is stabilized due to resonance. Because of that, phenol is more acidic. Now this one goes here, so we have O double bond. Here we have minus sign. Again this one comes here, this one comes here, this one goes here. So what do we have? Minus sign here. Again this one comes here, this one goes here, and we have this. Again this one comes here, this one goes back there. So we have O minus, like this. So these are the resonating structures, okay, and it is clearly seen that the negatively charged is spread throughout the benzene ring. So this is the delocalization of this negatively charged, okay. So because of this, due to resonance, the phenoxide ion, this phenoxide ion is stabilized. Hence phenol is more acidic as compared to the other three. And in water, oxygen is more electronegative than hydrogen, so it will take the electrons towards itself, and we have what? We have H plus, OH minus. Now let's come to these two. These are alcohols, but why is methyl alcohol more acidic than ethyl alcohol? C2H5 OH, or we can write this one as CH3 CH2 OH. Now here we have the higher alkyl group, right? So this one increases the electron density on oxygen atom by positive inductive effect. Because of the positive inductive effect, the electron density on oxygen atom is more. So because of that, oxygen cannot the tendency of oxygen atom to take another electron from hydrogen decreases. So it becomes difficult for oxygen atom to take another electron from hydrogen atom towards itself, thereby the release of H plus is difficult. Now let's have a look at methyl alcohol. Here this one increases the electron density on oxygen atom by a positive inductive effect. But here we have only one methyl group, so here the electron density is not so high as in the case of ethyl alcohol. That's why this one is more acidic than what? Than ethyl alcohol. Hence the increasing order for the acid strength is in this way. Okay. Second one, why electrophilic substitution in phenols takes place at ortho and para positions. Here you should know the structure, the structural formula of what? Of phenol. So this is your phenol, right? OH group is attached to the benzene ring. So you have like this. And here we have two lone pairs of electrons. Now, these two comes here, these two goes here. So you have a minus sign here and here positive. Again, this one comes here, this one goes here. Again, this one comes here, this one goes here. Again, this one comes here, this one goes back here. So you have this. These are the resonating structures of phenol. If you look here, you will see that the electron density is high where this is your ortho position, this is your para position, this is your ortho position. So the electron density is high at the ortho and para positions. That's why when electrophile comes, it would go to attack at the ortho and the para position. That's why electrophilic substitution in phenols takes place at ortho and para positions. Next, why are alcohols more soluble in water than hydrocarbons of comparable molecular mass? You should have the concept of hydrogen bonding. This is the general structural formula for alcohol, and this is for alkene, where R is your alkyl group. In alcohol, we have hydrogen bonding, but in alkene, we don't have a hydrogen bonding. Now, hydrogen bonding is possible in alcohol because of this electronegative oxygen atom. Like this. So in this way. Now this one with another one like this. It goes on in this way. So there is a hydrogen bonding in what? In alcohol. So because of this hydrogen bonding, when you dissolve this alcohol in water, this one also is able to form a hydrogen bonding with water. So because of that, alcohols are more soluble in water than alkene, because in alkene we don't have hydrogen bonding. So if we don't have any hydrogen bonding, then this one will have no tendency to form hydrogen bond with water. That's why it is less soluble in water as compared to what? Alcohol. Next one, 20D. Give the chemical test to distinguish between phenol and benzoic acid. Suppose you are given two test tubes where you have phenol and benzoic acid. Let's say here you have phenol and here you have benzoic acid. Benzoic acid. Now you want to test which one is a phenol, which one is a benzoic acid. At first you don't know, okay, which one is a phenol, which one is a benzoic acid. Now there are two tests by which you can perform to know which one is a phenol, which one is a benzoic acid. The first one is a sodium bicarbonate test, another one is a ferric chloride test. You can choose any. So I'm going to teach you by sodium carbonate test. Let's see. Sodium bicarbonate test. If you take a phenol and you add what? Sodium bicarbonate to it. Sodium bicarbonate, there would be no reaction. I will tell the reason why. Now, let's take a benzoic acid. This is your benzoic acid. Now, what you do to this, you add sodium bicarbonate. So, in this case, you will have C double bond O, O minus Na plus, H2O and a carbon dioxide. Once you add sodium bicarbonate to benzoic acid, you will see an effervescence of carbon dioxide. If you see that, it is confirmed that the compound is a benzoic acid. Now here, why the reaction does not take place here when you add sodium bicarbonate to phenol? This is because phenol is a weak acid than benzoic acid. That's why it does not give this reaction. Okay, so this is the test by which you can perform in order to distinguish between phenol and benzoic acid. And the second one you can do by the ferric chloride test. You can give only one because it is for 1 mark. Okay, now let's come to 20E. Explain the following observations. The first one, the boiling point of ethanol is higher than that of methoxymethane. Here also you should have the concept of hydrogen bonding. Ethanol, CH3, CH2, OH. Methoxymethane, CH3O, CH3. In ethanol, what happened? There is a hydrogen bonding. One alcohol molecule forms a hydrogen bond with another one, like this. So it goes on in this way to form a hydrogen bond. And to break this hydrogen bond, we need to apply a high amount of energy, which is why the boiling point of ethanol is high. Whereas in methoxymethane, we don't have hydrogen bonding. That's why its boiling point is lower than that of what? Of ethanol. Hence, the boiling point of ethanol is higher than that of methoxymethane because of hydrogen bonding. Second one, phenol is more acidic than ethanol. Same concept, phenol oxygen is more electronegative than hydrogen, and here we have a phenoxide ion, right, and a proton. I have explained to you that this phenoxide ion is stabilized by resonance. Because of that, it is a strong acid. Okay, whereas ethanol, CH3, CH2, OH, here when it dissociates, it gives alkoxide ion and a proton. Now here we don't have resonance, no resonance. And this negatively charged, okay, is concentrated only on the oxygen atom. Since there is no resonance to stabilize this alkoxide ion, it is a weaker acid than phenol. That's why phenol is more acidic than ethanol. Okay, so this is done for question number 20, and in the next video I'll continue with question number 21 from organic portion, same year 2022 board exam MBOSE.